Ratios and rates. We're on page 275. We're on page 275. Archery. An archer shoots 60 arrows at a target, and with 44 arrows hitting the scoring area and 16 missing the scoring area. How can you evaluate the archer's performance? You can compare the archer's numbers of hits to the archer's numbers of misses using a ratio. So if I were to do that, how would I do that? I have 60, right? I shot the arrow 60 times, and 44 times it's going to hit the scoring area, which is somewhere in here, right? And then over here, I'm going to hit 16 or just out there, right? It's completely out there. How would I say? What would I say? If you're the commentator, what would you say?
44 to 16.
Okay, so the hit to miss ratio would be 44 to 16, right? Or we can write it as 44 to 16, correct? It's also written as that way. Is there another way where we can write a ratio? 44 point or colon, right? And then 16, correct? You can do it this way. So it's kind of like you're watching a basketball game and the guy comes up to shoot a free throw and it says, he is 85% free throw shooter, right? And he comes up and shoots it, and so that's kind of the same thing here, correct? This is what we're kind of describing. We're trying to describe using the rates or the ratios here, okay? This is what we're trying to convey that, okay? So if you look in the middle of page 275, it says A to B, A colon B, A over B. We talked about that, right? So let's go ahead and delve into example number 1. It says, use the archery information given above. Write the ratio in 3 ways. A, number of hits to the number of misses. Number of hits to the number of misses. So this is what we're doing. Hits to the misses, right? So we can write it this way, or this way. And actually, this is reducible, right? So 4, 11. So it's the same as 11 over 4. You can write it that way. B, number of hits to the number of shots. Now, this is how we traditionally talk about basketball, right? You're going to say, okay, I have attempted, free throw made, field goal attempted, field goal made, right? So yeah, Reggie Jackson is shooting, he's made 15 out of 20 shots. That's how you're going to see it, right? That's how it's going to come out, right? So we're going to have 44 hits of the total of 60 arrows, correct? In other words, we can write this as 44 to 60 or 44, 60, not 66, 60, right? 60, okay? So that's how we can write it. And again, this is reducible to what? 11 over 15, right? 11 over 15, so it would be 11 over 15 or 11 to 15 or 11 colon 15, correct? Okay. Flip the page, let's go to page example number 2. Example number 2, biology. Cooper, would you read the example for us?
The ratio comparing the length of a bird's wings to the average width of the bird's wings is the bird's aspect ratio, or the birds in the table from the greatest aspect ratio to the least.
Okay, all right, great, thank you. So the aspect ratio is the width of the bird's wings, so it's the length of the bird's wings to the average width of the bird's wings, okay? Aspect ratio. So if I have a bird, okay, I'm gonna make a very bad attempt to go ahead and draw this. Looks like it's like this, right? with the beak. Okay, so the aspect ratio would be this guy to this guy, right? Is that what that's what they're saying? Right? That's what they're saying. Okay. So we have the white-tailed eagle would be 209 to 30, right? Whereas the European jay would be 47 to 12. And then there is 83 over 8. And that is for which bird is that? The black-headed gull. Okay. So before you put it in your calculator, before you look at it, which one's going to be the highest? I want you to make an educated guess. Tell me which one's going to be highest. I have 1, 2, 3. Which one looks the highest?
Number 3.
Why?
Because 83
Just is.
over 8.
And you said this one because why? Because the number is bigger.
Yeah.
Okay, all right.
I don't know if it's right.
83 over 8 is about 10, something a little over 10, right?
Uh-huh.
Just in your head, a little overhead, right? 10, right? Okay. 209 over 210 over 30 is what? 210 over 30 would be 7, correct? So this is almost 7. So this guy would be number 1. This guy would be number 2 because it's almost 7. This guy here, if I had 47, but instead if I had 48, what would it be? 48 divided by 12 is 4, correct? So this is almost 4. So we're trying to eyeball and just get a sense. Almost 7, almost 4, little over 10. Right? We might not know the exact numbers, but I can go ahead and say, well, this is the highest, this is the next, this is the next. Right? Okay. All right, so that's that. And then we have rate. There's a little paragraph there in the middle of 276. Grace, can you read that for us?
A ratio. A rate is a ratio of two qualities measured in different units. A unit rate is a rate that has a denominator of 1. When expressed in fraction form, unit rates are often expressed using the word per, which means for every.
Okay, so every, right? So per, so like, right? So that's one of the things when you go, especially when you go to like Costco and you're trying to buy something, right? And you have these humongous quantities of things, right? When you go to Costco, everything's like huge, right? You go, there's these Starbucks boxes of K-cups there. I don't know. What do you guys buy when you go to Costco? Does anybody go to Costco here? What do you buy? What do you like to buy?
My parents do.
Okay, well, what do you guys get?
We get like boxes of snacks.
Boxes of snacks, okay? So for that, for people like you or me or who don't want to sit there and do all the calculations, every single price tag on Costco will have a unit price. It'll say, okay, oh, it's like, $2, I don't know, $16, $16.99 for 40 of them. And then it'll say, well, this equates to a unit price of, so many dollars per unit. Okay? The same thing, that's what we're talking about here, right? So example number 3, you host a party for 12 people. The food and drinks for the party cost $66. So you have $66, right? So you're gonna have, this is example number 3, you have $66, and this is for 12 people, right? So you're gonna be interested in how much money I spent per person, correct? So you're gonna take this guy and divide it by this, right? So let's see what happens. When I do this, I'm gonna get 66 divided by 12, which turns out to be $5.5. So I'm gonna get $5.5 per person. Okay? Which is what I'm trying to find out, right? How much money did I spend per person? If I do this the other way around, what kind of unit am I gonna get? I'm gonna get 12 people over $66. Do I want to know, am I interested in how many people per dollar? No, I'm not, right? I'm more interested in how many dollars per person. So you should look at the units. If you have any doubt of which one you're going to divide into the other one, think about it. Just, see which one makes common sense. Okay. So that's how you would do that. Let's go to example number 4. A jet flies 540 miles per hour, right? It's rate in miles per minute. Rate in miles per minute. Okay, this is a handy number for you guys to kind of keep in your back pocket. A plane flies about 500 miles per hour. If you're interested to know how many hours it's going to take for you to fly from here to LA, right? Or here to Miami or whatever. Look at the miles divided by 500. That's how many hours it's going to take. You would probably want to add another hour between landing and touchdown. Okay, but it's a good number to have. Example number 4. So I am traveling 540 miles per hour. What does it want to know? It wants to write this rate in miles per minute. So I like the miles. I want to keep the miles, but I want the hours to be in minutes. So this is what we call a what? I'm going to multiply this by what is known as a conversion factor. So I'm going to convert the hours to minutes. How many hours are there in a minute? 60, okay? So here we go. I have a choice. I can either go 1 hour is 60 minutes, or I can go the other way around, right? What happens here? Do anything count? They don't cancel out, right? Because I have hour in the bottom, 2 hours in the bottom, and 1 minute on the top, right? So obviously this is not the correct way. The correct way would be I would flip these over and go 1 hour is 60 minutes, right? Now look what happens. Like these hours cancel out. I'm going to end up with miles per minute. And that's what we want to be, right? That's what the question asked, was miles per minute. So, okay, so this is the way I'm supposed to do it. So, because what I have left over is miles per minute. So it's going to be 540 divided by 60 miles per minute. Zeros cancel out. 9 miles per minute.
Oh, I was just saying, but looking at that though, couldn't you just start with 540 divided by 60 though?
It's something like this, is you can do that, but things will get more dicier and a little more complicated as you move along in your math career. So I'm just letting you know this would be the proper way to do it. Okay. And again, use the units to your benefit. Use the units to your benefit. Okay. Okay, let's go to number 5. Engineer designed a miniature robot that can crawl through pipes and vents that humans can't access. The robot travels 1 inch in 3 seconds. How many feet does the robot travel in 4 minutes? So I have it's traveling 1 inch per 3 seconds. 1 inch per 3 seconds, right? And I want to transfer this into feet and minutes, right? Inch and seconds, I need to transfer this to feet per minute, right? I'm just in feet per minute, right? So inch and feet. I have to go from inch to feet. How many inches are on there a foot? 12, right? So I'm going to put, I want the inches to cancel out. So I'm going to put the inches in the bottom and I want the feet on top. So it's 1 foot is 12 inches. Now the inches cancel out. I have the feet, which I'm looking for, but then I'm looking for it to be in minutes, right? I want this to be in minutes. So again, I'm going to do the conversion factor, and I want the seconds, since the seconds on the bottom here, I need the seconds to be on top. Seconds, minute. So 1 minute is 60 seconds. Seconds cancel out, and again, I have now feet per minute. So the speed is 1 times 1 times 60, 3 times 12 times 1. And I'm going to end up with feet per minute. Right? This cancels out at 5. Right? So I have 5 over 3. So 5 feet per 3 minute. Right? I would travel 5 feet in 3 minutes. And that question was, how long would it far would it travel in 4 minutes? Correct? So all I have to do is take this number, 3 feet per minute, and multiply this by 4 minutes. So the minutes now cancel out. 20, 5 times 4 over 3 feet. So it's going to be what? 6.6 repeating? 6.6666666. So that's your answer. And we're done.